Newton's third law is all about the interactions between two objects. And it turns out that the interaction is equal in size and opposite in direction, acting on each of those two objects. Okay, so let's actually now sketch out an example here. A chandelier hangs from a rope, which hangs from a ceiling. Let's draw a physical diagram of this situation. Ceiling, rope, chandelier, and a force diagram for the chandelier, then the rope, then the ceiling. And we're going to label what we call Newton's third law force pairs as they occur in this situation. So let's first start with the chandelier. So for the chandelier here, I need to recognize that there are two forces, two interactions happening on the chandelier. I hesitated there for a moment. I wasn't sure what to call that upward force. So the downwards force, F gravitation by the earth on the chandelier, F tension by the rope on the chandelier. The sum of these forces, or the net force, is F tension minus F gravity. And that's zero. Everything's balanced out here. The safe assumption is that this system is at rest. So now I've got a rope here. We'll just draw like a little section of it. So the rope itself. So there is a downwards tension on the rope by the chandelier. And there is an upwards tension by the ceiling on the chandelier. Ceiling on chandelier. And fun little silly thing about physics is we often assume that ropes have no mass of their own. So I'm just going to leave this situation like this, and I'm going to assume again that it's all at rest. So everything balances out. All right. Now, the third object is the ceiling. Okay, the ceiling is a little bit weird because it's attached like to a building and everything else. But for now, let's just treat the ceiling in isolation. So you're not often going to need to draw force diagrams of static objects in the surroundings. So this, like I said, it's a little weird. All right, so the chandelier is being supported by the ceiling. I've underlined it here in my diagram. And so I need a downwards force, F tension by chandelier on the ceiling. And to support that, I need some sort of upward force. And this is where it gets a little weird. We're not necessarily going to see problems like this too much in class. So there's some sort of F applied by something on the ceilings. Something is holding the ceiling up. Maybe it's the ground, maybe it's a normal force. But this is not really where I want to focus our attention. Instead, I want to focus our attention on what Newton's third law says about a couple of these forces. You'll notice that there's a tension force by the rope on the ceiling, and there's a tension force by the ceiling on the rope. Those are actually both ends of the same interaction. They are identical in size. So I'm going to use a little red hash mark here. Boom, boom. Those are the same size. They're actually the same interaction. Newton's third law says that the interaction between two objects is equal in size and opposite in direction. Do you notice that those two forces are happening on two different objects? That's what Newton's third law is all about, is about forces that act on different objects. Let's look for another Newton's third law force pair. So you'll notice here F tension by ceiling on chandelier and F tension by chandelier on ceiling. Again, those are, as it turns out, the same interaction, just looking at it from a different point of view. So they're the same magnitude force. Now, here's a fun thing to notice. The labels on Newton's third law force pair, F tension by ceiling on rope by rope on ceiling. Do you notice how Newton's third law force pairs, the two highlighted here in yellow, for example, they just reverse the order of the labels. And the same thing here, F tension by ceiling on chandelier, and then F tension by chandelier on ceiling. Weird one because both those are the letter C. But in Newton's third law force pair, look for the labels to be reversed and always look for them to be on two different objects. Okay, Newton's third law forces are both sides of the same interaction happening on two different objects. What I mean by swap the by and on labels is I'm referring to the way that these labels here, by ceiling on rope, by chandelier on rope and by rope on chandelier, for example. And they always act on two different objects. Always, always, always. This is a useful way to think about Newton's third law. Thanks for coming along with me on this little adventure about Newton's third law. Please fill in your own graphic organizer about Newton's third law that I handed out to you previously in class.